He's a technology officer of StraightFlo Valves, founded in 2010 and headquartered in Houston, Texas. And they develop and market a unique and groundbreaking compressor valve based on the modular reed valve technology developed by StraightFlo Corp in 2009. Prior to this, StraightFlo was chief engineer of Samsung TechWinds Power Systems Group, established a Center for Excellence, turbo machinery design in Houston, and overseeing Samsung's compressor technology in South Korea and the USA. This division of Samsung has since been spun off as a Hanwha compressor company. His previous experience includes principal engineer at Cameron, where he was responsible for new centrifugal compressor design in Buffalo, New York, turbocharger design in Salinas, Kansas, reciprocating compressor design in Houston, Texas, and Ajax engineering compressor development in Oklahoma City. He is an aeromechanical engineer, or was at York International, responsible for the development of next generation chillers. He started his career at Atlas Copco in New York, responsible for rotordynamic and aerodynamic design of centrifugal compressors. He held senior engineering R&D positions at Atlas Copco's Compressor Technology Group in Voorheesville, New York, and at AirTech in Antwerp, Belgium, and was responsible for the development of several compressor cares for process gas compression and air compression, centrifugal compressors, oil-free, oil-injected, and water-injected screw compressors and scroll compressors. StraightFlo is a leading technical authority in the field of compressors, refrigeration, rotor dynamics, vibration analysis, troubleshooting, including bearings, seals, valves, and has several utility patents and inventions in these areas. StraightFlo received his BS in mechanical engineering from the College of Engineering in Trivandrum, his MS in mechanical engineering from Texas A&M and College Station, and his diploma in international management from the Swedish Institute of Management. Over the years, StraightFlo has been active in various community and professional organizations. He's coached youth soccer for several years, served as a chairman for the STLE Hudson, I'm going to let you explain what that is, and was an active member of the Vibration Institute, Texas A&M University Consortium, and the GMRC. And without further delay, I apologize if I was blocking the screen with my paper. StraightFlo, go ahead and take it over. It's all you now.
All right, thanks. Thanks, Jeff. Thanks, Drew. Let me go ahead and share my screen, right? Compressor valves are the most critical components in a compressor because it determines the efficiency of the compressor or how much power that it is consuming. It also determines how many times the compressor has to be shut down to service it because it's a valve that fails the most number of times. So if you take a look at this chart over here, which is a study that's been done several times, the number one cause of unscheduled shutdowns in a compressor are basically the compressor valves. And it accounts for about 36% of the shutdowns. The closest second is basically the packing rings, and that accounts for about 17 to 18%. So a compressor which is running at 250 RPM, the valves are closing, for every rotation of the crank. So if a compressor is running at 250 RPM, the number of cycles opening and closing of the valves is about 131 million cycles. And in the case of a faster compressor, 1800 RPM, which you commonly see upstream, it's opening and closing almost 1 billion times a year. So this slide shows you pictures of the typical conventional valves that you see today. So on the left you have the plate valve, you have the ring valve, and then you have the poppet valves. So in the case of all these valves, you have the valve seat, which actually is responsible for taking the pressure differential across the valve. You have the sealing element, which is the plate in this case, the rings in this case, and the poppets in this case. And the sealing elements are basically actuated by springs. And the spring is guided inside the guard of the valve, and the guard is also responsible for controlling the lift of the valve. So this slide shows the evolution of valves over the years. So the plate valve was invented in 1895, and if you take a look at the plate valve, the design of the valve, the flow of the gas through the valve hasn't changed since it was first invented. Similarly, the same is true for poppet valves, which was invented in the 1950s, ring valves, which was introduced in the 1930s, and channel valves in the 1940s. So the major issues with conventional valves are as follows. So number one issue is, the valves, when they fail, they have to be serviced. In order to service a conventional valve, you need to take it outside of the compressor. You need to send it to a precision machine shop, and there they will actually check the valve seat and guard against a drawing to see whether it's within spec. If it's within spec, you would machine it and bring it back to its good condition. And you would always replace the internals, which is either the plate, springs, etc. And this requires a long lead time. It also requires skilled labor, and it also requires the user to have a full set of spare valves on site. The other big issue with valves is that it's the number one cause of unscheduled shutdowns, and the mean time between service in a valve really depends on the application, but in the case of upstream application where the quality of the gas can be bad, it can be anywhere between 3 days to something like 6 months. In the case of pipeline transmission applications where the quality of the gas is clean, in the case of a high-speed compressor, the service interval is more like a year for valves. In the case of downstream applications, typically it's about 2 years, but in dirty applications, you see things like a couple of months. The other problem with conventional valves, or with valves in general, is that it is responsible for consuming a lot of power. So in the case of a conventional valve, the gas that flows through the valve has to make at least 2 right angles as it goes past the element. And every time it makes a turn, or it kind of mixes with the gas coming from the adjoining ports, there's a pressure loss, and a pressure loss means increase in power. So the last problem is that, with a conventional valve, you have to have a large inventory. So typically an end user will carry a complete set of spare valves. And in the case that you want to repair your valves yourself, then you have to have the different plates and springs for the different applications, as well as different sizes of valves. So you could have thousands of parts in your inventory. So the StraightFlo valve is a patented drop-in compressor valve, and there is no requirement for modifying the cylinder of the compressor. So the smallest diameter that it comes in is about 1.5 inches, about 38 millimeters, and there's really no upper limit. So we have valves which are more than 14 inches in diameter. So there are more than 15,000 of these valves currently running in the field, and they are in all brands of compressors, including Ariels, Coopers, Dressers, Ingersoll Rands, etc. So the valves running in applications which range from 200 RPM to more than 3,600 RPM. The maximum pressure differential that a valve can take across a single valve is 4,350 psi, about 300 bar. And the temperature it can be used in is anywhere from cryogenic minus 300 degrees Fahrenheit to 500 degrees Fahrenheit continuous temperature. So these valves have an industry-leading 10-year warranty on the stainless steel housings. And in slow speed applications with pipeline quality gas, we also have a warranty of 5 years. And in the case of downstream applications, typical, it's about 3 years. So these valves actually improve the reliability of the compressor by anywhere from about 5x to 15 times. That is the mean time between shutdown of a compressor due to valve issues. And we actually guarantee that this will be at least 2 times that of the previous valve for the same conditions. So because of the design of the valve, compressor power can be reduced by anywhere from 3 to 15%, depending on the application and speed of the compressor. And in cases where the clearance can be reduced, you can actually use the power that is saved to push the same amount of gas through the compressor. So you can increase the throughput of the compressor by anywhere from 3 to 15% in these applications. So you will see that these valves are the easiest to service. It really takes about 5 to 10 minutes per valve, and it can be done on site, and there's no machining involved. And because of the modular nature of the valve, it reduces the inventory by more than 80%. There's no need to have a full set of spare valves for a compressor. So on the ESD side, these valves reduce emissions and also reduces noise and vibrations. And because, again, of the design of the valve and the fact that the valve is not consumable anymore, these valves lend itself to rental programs. We actually rent these valves or lease these valves. So these valves have been applied in different markets, so it can be used in all aspects of natural gas, from production, gathering, transmission, injection, etc. And we also have valves in refinery and petrochemical applications, as well as industrial gas applications. So these are some of our customers on over here, and this picture shows our standard valve, and this shows a range of valves with different sizes and different types. So essentially these valves are modular reed valves. So basically you have a valve seat, and we call this a valve carrier because it's really not a guard. Its function is purely to carry these modules, and inside the valve you have a number of modules. These modules are all the same size or dimensions on the outside, so whether the valve is 1.5 inches or it is 14 inches, it has the same modules in it, but the 1.5 inch valve has got less number of modules than the 14 inch valve. So these modules can be interchanged between these valves, and you can see that these modules are actually held stationary between the valve seat and the valve carrier. In order to service these valves, all you do is you remove these modules using your hand. There's no special tools are required, and you basically remove the bad modules and replace it with good modules. So this can be done on the compressor site. There's no machining involved. There's very little skill involved, and it takes 10 to 15 minutes to do that. So this picture actually shows you kind of a cross section of a module. So you have basically a triangular part with reeds on either side, and when there's a high pressure on the inlet side of the valve, the reeds actually deflect and allow the gas to flow through. The gas flows through in a straight line, and there's very little turbulence or mixing, and as a result of that, there's less amount of power required, or the valve losses are much lower than that of conventional valves, where the flow has to go through a tortuous path through the valves. So the valves are actually optimized for different applications. So whether it's running in hydrogen at 200 RPM or if it's in natural gas at 1800 RPM, the way we optimize these valves for the given application is by changing the thickness of these reeds, or by changing the lift, that is the amount that the reed can move. So this is internal to the modules, so the external dimensions of the modules are exactly the same, and so we have different combinations of reeds as well as lifts, but for the complete reciprocating compressor application, from 200 RPM to 3600 RPM, different gases, etc., we only have a relatively small number of combinations. So there are probably about 16 to 18 different part numbers of modules in a given material to handle this complete range of reciprocating compressor applications. But a company that is using a particular gas and a particular application, for all the compressors in that particular company, for instance, company-wide, you're probably looking at maybe stocking about 8 to 9 module part numbers for all your compressors, irrespective of the brand of the compressor, and irrespective of the size of the valves, irrespective of the operating pressures. So you're only talking about 8, 9 part numbers of modules. So, and because it's so simple and quick to service these valves, and you don't have to send it out in order to be machined, etc. You really don't need to have a set of spare valves, complete set of spare valves. So you can actually reduce your inventory by more than 80%. The other advantage of the fact that these models are interchangeable is that if you're responsible for maintaining a fleet of compressors which is out in the field, then all you need to do is have about 4 or 5 boxes of modules in the back of your pickup truck. You can drive up to a compressor, determine whether there's an issue with a valve or not by shooting the temperature on a valve cap, for instance, and you can actually repair it right there without having to go back to pick up another valve, for instance. So if you take a look at these valves, the models are stationary. So the plastic in the models is not, going up and down and hitting against the valve seat and the valve guard. And as a result, these valves are much more reliable than conventional valves. Moreover, the flow of the gas is straight through. So even if you have liquid or a solid which goes through this valve, actually it goes through and it does not impact against a hot plastic part, for instance. And as a result of that, what we see is 5 to 15 times increase in the mean time between shutdowns of a compressor. So these models also have been proven to have a much wider range of operating conditions that you can work in with good efficiencies. And because of the StraightFlo nature of the valve, this is why you see a 3 to 15% reduction in compressor power depending on the application. And this reduction in compressor power can be converted into throughput if you can reduce the clearances or increase the speed of the compressor. So these valves are also considered to be self-cleaning, so it does not get clogged up if you have powder or something else or clay kind of thing in the gas stream, because it actually keeps blowing it out, and there are no deposits that are in the passages. They just get blown away. So these valves also considered to be green because they actually can reduce the emissions in a compressor. Many people think in terms of packing rings when they think about emissions, but actually one of the biggest contributors to emissions is actually the reliability of valves. Every time a valve has to be serviced, a compressor has to be shut down and opened up, and the gas is trapped in the compressor, and a portion of the pipeline is actually escapes into the atmosphere. Moreover, when the compressor has to be put back online, you have to purge the line, you have to probably flare, and so the less number of times that you have the compressor shuts down to valve issues, the less the number of emissions. And so when we can increase the mean time between shutdown by a factor of 5 to 15 times, we are saying that the number of this kind of emissions has been reduced by a factor of 5 to 15 times. So this infographic basically shows the difference in servicing a conventional valve versus maintaining a StraightFlo valve. So based on what I've already talked about in the previous slide, the cost of maintenance of a straight flow valve is much lower than that of a conventional valve. First of all, the failure rate of the valve is much lower than that of a conventional valve. And when you do have to service it, you don't have to send it out, you don't have to machine it. It's very easy to replace the modules. The inventory is low, so there is a lot of savings. You don't even have to leak test these valves as you would have to with a conventional valve, because every module actually comes leak tested, and the module actually seals against the valve seat, which is not machined, which is not changed from the factory condition. So the cost of maintenance of these valves, maintenance of the compressor, is much lower than with conventional valves. So this shows you our dynamic simulation program, which is used to simulate a valve in a given compressor for a given application. So the output of the code includes the pressure on either end with as a function of crank angle, the PV curves on the head and crank end, and this is actually the movement of the reed as a function of the crank angle or the lift. And you can see here that no assumption is made that the valve is fully open when the pressure differential reaches a particular point. And this actually gives you the rod load. So it's a combination of the inertia load and the gas load. This is a picture of our standard valve, and this shows you our valve with an integral cage. Our valves can have integral cage because it's no longer consumable. So this is the valve protection mesh which was introduced 2 years ago, and what it does is that it protects the valve as well as the cylinder from liquid slugs as well as solid foreign objects inside the gas stream. So these are used only on the suction valves, and it's the last defense against these things. It can cause a lot of damage. These are valves which are called high efficiency valves, because what we do here is within a given diameter of a valve, we can put a lot more modules in it, which actually increases the flow area of the valve much more than our standard valve. So our valves can be unloaded. So in the case of plug style unloader, we have a drop-in replacement valve which works with your existing actuator. You don't have to change your actuator. So we also have drop-in replacement for finger cell unloaders, and this is a valve that will use your existing actuator and replace your existing valve with the finger unloaders on it. So in fact, we've got 3 different unloader technologies that we use with our valves, which are much more reliable than a finger unloader, where you have a metal finger trying to push down against a highly stressed plastic plate, for instance, which can cause reliability issues. So some more valves that we also have concentric valves. So this is a valve that goes into a gas jack compressor, and this is a valve where we've integrated the valve cap as well as a cage, and this goes into a GE H302 compressor. So these are products that are used in compressor stations pretty much. So this is replacement for a double-decker valve. This is a replacement for a parallel flow valve, and this is actually a new valve that has much higher efficiency than double-decker valves or parallel flow valves. So we are seeing a drop in power of about 15%, which can be converted to 15% increase in flow in a compressor station per unit, per compressor. So we also make scavenger valves for two-stroke engines, for instance, and these use exactly the same modules that we use in our valves. So there are a lot of old compressors, especially Ingersolls and Dresser-Rands, in which the valve is retained by a jack bolt, and these valves are notorious for being difficult to maintain, issues with emissions and difficulty in tightening the valve cap bolts versus the jack bolt. So we have a field conversion for this valve where we replace this jack bolt cage with a cage and a valve cap with an O-ring. So we put in a conversion ring in the cylinder. There's no machining required. Like it's a drop-in kind of thing. It takes maybe 15 minutes per valve location, and we use a valve and solve the problem of maintenance and reliability that you have with jack bolt restrained valves. So this chart actually shows you the increase in performance by putting a StraightFlo valve in a Cooper compressor, Cooper WG66. The details of the compressor provided over here. So compared to a poppet valve, which was actually the best performing valve in this test case, the StraightFlo valve actually provided a 8.2% reduction in horsepower, but also had an increase in flow of about 1.25% because of the lower clearance of the valves, which resulted in improvement in specific power about 9.3%. But you can see here that in order to get a 9.3% improvement in specific power, the valve losses had to be reduced by 41%, which is a significantly large number. So here we see PV curves that have been measured in the field using Windrock, and this is the PV curve for the original valve which is a plate valve, and this is in the case of a White Superior MW68 compressor running in Permian natural gas, and this is with the StraightFlo valve. So you can see by the shaded area on the discharge, which shows the valve loss on the discharge side, that the area with the StraightFlo valve is much lower, which means that the valve losses are much lower. So this is a Windrock measurement on the valve caps of an aerial JGD running at about 1100 RPM. So here are the ultrasonic measurements, the pressures on the head end and crank end, and you can see that the ultrasonics captures the opening and closing of the valves, the noise. And so this is what it looks like with the plate valves. And then when you replace the plate valves with StraightFlo valves with the same resolution, you can see that the noise is extremely low. You can hardly see anything, and so the noise with StraightFlo valves as well as vibrations is reduced considerably with StraightFlo valves. So here's some case studies. This is a Gemini D504. The valves installed in 2013. These are the running conditions, and this was the condition of the suction valves. Every 30 days, these valves, the compressor would shut down and the valves would have to be serviced. So we put the StraightFlo valves under exactly the same conditions in this compressor. So from shutting down every 30 days, these valves ran for 31 months with requirement of only 3 shutdowns in that period to service just one valve on the third stage. So that was a big improvement in reliability, getting rid of all these downtime and lost production. So there was a big savings over here. So this is another application, in this case a high-speed 1800 RPM aerial, 140 horsepower, and in this application, natural gas. This is the discharge valve on the last final stage. The suction valve looks good. So this is coming out of the gas inside the cylinder due to pressure and temperature. And when this happens, this valve cannot be cleaned. It has to be thrown away. So this used to happen every 3 to 4 weeks. The question was whether the StraightFlo valve could handle this. But when the StraightFlo valve was put in this application, you can see that there was a deposit of the salt on the flat part of the valve, on the seat of the valve, but actually the modules are clear because it's self-cleaning and blows straight through. So this valve was inspected after about 3 months just to see how it was. The salt was removed by hand and the valve was put back in. And in fact, from 3 to 4 weeks. This valve has been running continuously since 2014 without one shutdown due to valve issues. So this is an application in the Eagle Ford Shale area, aerial GG4, 1500 RPM, and it has about 30% hydrogen sulfide in the gas. And this compressor used to shut down every month pretty much. And that was a big problem because of the SAR gas, which was a safety concern. So after installing our valves, the compressor has not shut down since. And as of February 2020, there's already a 14 times increase in the mean time between shutdown of this compressor. So this is an application in a compressor station, and in the case of a Cooper Bessemer GmbH10, so the compressor is running at 330 RPM with the typical 541 PSIG suction, 761 discharge. So this compressor had an issue with reliability. It used to shut down every couple of months. So the valves were installed in August 7, 2018. Since then, the compressor hasn't shut down once because of valve issues. So already there's an increase in the mean time between shutdown by a factor of 6. But on top of that, there's also this compressor has about 4.4% more flow with 1.9% better specific power. And the windrock measurements indicate that the valve losses have been reduced by 14.6% in this compressor, a slow speed compressor. So here's a refinery application where in a hydrogen compressor, which was shutting down every couple of months, the StraightFlo valve actually resulted not only in improvement in reliability, but also reduced the horsepower by about 7% on the compressor. So because of the improvement in reliability, several of the compressors in that particular refinery have been converted to StraightFlo valves, and so these are some of the compressors and the applications in which it's applied. So this is a critical butane mix compressor, Ingersoll Rand, running at about 360 RPM. And this compressor is shut down every 3 to 6 months, causing production downtime. The StraightFlo valves have been operating continuously for 2 years, and there's also the advantage that these valves don't have to be sent out for repair. So to summarize, the StraightFlo valve is a drop-in replacement for existing reciprocating compressor valves. It increases reliability by a factor of 5 to 15 times, and we guarantee at least a 2 times improvement in the mean time between shutdown of a compressor for the same operating conditions. So it's a much more efficient valve, resulting in lower valve losses and lower power. Typically see anywhere between 3 to 15% lower compressor power depending on the application, and that compressor can be converted to throughput if it's possible to increase speed or reduce the clearance. So these are the easiest valve to service, taking about 5 to 10 minutes per valve on site, no machining involved. And also there's you can reduce inventory by more than 80%. Okay, thank you so much. So if you have any questions, I can answer them.
Hey, Zaruf, this is Chuck Irby, and I just had a question on lubrication. What are the impact of lubrication? Since we got Sloan coming up here soon, what have you noticed about changes to modification or lubrication requirements, if any?
So these valves can work in lubricated cylinders as well as non-lubricated cylinders. And what we've seen is that in those cases where valves have failed because of over-lubrication, these valves, because they can handle liquids better, they last much longer in the case where cylinder is lubricated. But it can handle, lubricated cylinders as well as non-lubricated cylinders.
I don't know. I can't see on the chat side. Are there any other questions from anybody in the audience?
Yeah, if you guys are there and you have a question, all the lines are muted, so please be sure to unmute yourselves or submit a question on the chat.
I guess I'll just show you one thing. I can find it. I just messed up my. So if you're wondering how this works, basically, if you can see this, the video. So this is the standard valve, and basically the way that that it's designed, you can see that these are the modules inside the valve. And in order to service this valve, all you need to do is use your finger. You push the module out with your hand, and that's how you remove it. And then you just put back the good modules, close it up, and it's ready to go. So there's absolutely, as you can see, these modules don't move up and down, so there's no machining involved. There's no wear on the seat or the guard, and as a result, that's why we provide the 10-year warranty on the seat and the guard.
What's the material of the modules? It's a non-metallic?
So this is a module that I can open up. Typically, the modules can't be opened up, but if these are the components inside the module. So you can see that's the outside part of it is what we call the pedal guard. That actually determines or limits the lift of the pedals or the reeds. And the inside is module body. It's a triangular part. And the gas flows from the top downwards. And the reeds prevent the flow. You know, if there's a backflow, it clamps down on the reeds and prevents the backflow. So when there's a high enough pressure, the reeds deflect and lets the gas go through. So during operation, this is what it's doing, right? And so in this particular case, these two parts are made of plastic, and this is made of a very high fatigue strength stainless steel. So there's no helical coil springs, and not only that, the natural frequency of this particular valve is in excess of 250 hertz. So if you think about a poppet valve, even with the heavier spring in it, the natural frequency of a poppet valve is less than 30 hertz, which means that if you're running at 1800 RPM, you're right on the natural frequency of a poppet valve. That's why poppet valves should be used at low speeds. In the case of a plate valve or ring valve, you can increase the natural frequency is higher. It's because there are several more springs supporting the plate. But still it's around 70 to 80 hertz. But in this case, it's about 250 hertz, so it's much higher than you know, any kind of excitation force that can be on the compressor. This, I just want to show you.
Our valves improve compressor reliability, working well with clean gas, dirty gas, gas with liquids, gas with solids, shale gas, and multi-phase gas.
So that's a quick kind of sketch of how the valve actually operates, how the reeds actually open up and allow the gas to flow straight through. And because the flow goes right through the valve, there's nothing that it doesn't impact against. So you can see that in the case of poppet valve or plate valve, if there are any particles in the gas stream, it's going to hit directly against the plastic part, which is hot and not as strong as it is at room temperature. Whereas in the case of this valve, once it goes through the module and the reeds are wide open, it just goes straight through. And if it hits something, it's hitting it tangentially on the stainless steel parts, which holds the strength even at high temperatures. And that's the reason why you have very high reliability compared to a conventional valve, even in the presence of dirt or liquids in the gas stream.
You mentioned earlier about rebuilding the valve, just changing the modules, removing a bad module and putting in a good module. What's the means of detecting good versus bad?
So again, we take advantage of the fact that the flow is straight. So in the case of a valve, all you need to do is, before you even disassemble it, you just take it like that and look at it, look through the inlet of the valve against a bright light. And if you don't see too much light, that means the modules are okay. So you can actually go through, I'm like, just by looking through it, you can figure out which modules are bad. And then you flip it and you look at the guard side of the valve, and here you can actually see the critical part of the valve, which is basically the reeds, how it comes together. So you can actually inspect the reeds just by looking at it without disassembling the valve. So that's how you would inspect it to see whether there's a bad module or not.
Thank you. We have a question about the materials. Is stainless steel the only material available for the reeds, or are there alternate materials?
So most of the applications we've got stainless steel, which is for about 80 to 90% of the application. And then in the case of corrosive gases, for example, if there's sour gas, we have applications in gases which has got more than 80% hydrogen sulfide. So there we have a special coating on the reeds, and then now that we are in chemical plants where we're actually handling gases like chlorine and hydrochloric acid, so we've got some special material alloy kind of reeds, as well as special coatings on the reeds itself to handle the corrosive gas. So that's a very small percentage of the applications. It's what you see in chemical plants, really. But for most of the other applications, the materials that we have in our standard valves can handle most of the gases that we see in oil and gas applications, as well as the most industrial gas applications.
And this is Chuck again. Are there any temperature or pressure ratio restrictions that you have to contend with?
No, so for the, so we've got the modules is what limits the temperature of the application of the valves. And we can go down to minus 300 degrees Fahrenheit, so cryogenic, all the way up to 500 degrees Fahrenheit. So in the case of those cases, we actually have aluminum modules which can handle the cryogenic temperature as well as the high temperature to 500 degrees Fahrenheit. The plastic modules can handle from minus 40 degrees Fahrenheit to about 400 degrees Fahrenheit. As far as the pressure differential is concerned, so the maximum pressure differential that a valve can handle is about, for our current design, is about 4,350 psi, which is about 300 bar. And so this is actually was developed for high pressure air application for ships, as well as for CNG applications, where on the fourth stage, you can see that kind of pressure difference across the valve on the fourth stage.
Thank you.